Justin, welcome.
Steve-O!
Watch out for the chickens.
Oh my gosh.
Yeah, we got chickens now, man.
Wow. Chickens in the podcast. Who knew?
Yeah. I mean, it is a barn. Unfortunately, it's also my office, so...
It's an unusual circumstance. Barn / IT professional office. I mean, that's probably makes you an unusual character.
Yeah. So, just want to apologize in advance for any loud squawks that people hear. High probability of some loud squawking.
Well, I'll try not to squawk myself.
Yeah, that's good. Appreciate that. These chickens are like about 4 weeks old now. And now we're at the phase where we have to go get a coop.
Ooh.
And that's like a major production, the coop purchasing.
It's going to be like a big advance. You're going to have to figure out where to locate the coop and what kind of coop to buy. It's a complicated process.
There's a lot to deal with. There's really only like one place that we can actually put the coop because the man came down and showed us you have to have it certain distance from the lot line and the house and all this stuff. I just wish there was like a service that they would just come and bring a coop and like throw the chickens in there and get the feed all set up and like the water and just make everything happen for me.
Well, you know, I really love the idea of the modern service, Steve. That's really something we need more of. It's actually interesting. You should bring up the idea of a service.
It is, and we'll find out why right after the introduction. Welcome to Device Squad, the podcast for the mobile enterprise from Propellix. Device Squad, fighting crimes against enterprise mobility worldwide. Bad UI, frustrating user experiences, poorly conceived mobile strategies, we defeat them all. This podcast series will cover all aspects of enterprise mobility, including strategy, development, design, testing, and more. My name is Steve Brickman. I'm a mobile strategist and UX architect with Propellix. First, a brief history of the company. Founded in 2011, Propellix is a mobile strategy consultancy helping enterprises worldwide devise true mobile strategies and develop world-class mobile applications across all industry verticals. Propellix clients include large companies like Amway, Bright Horizons, Bank of Montreal, Dubai Airports, Family Dollar, DLL, Cintas, Merck, and many more. Propellix menu of services includes 8 different mobile kickstarts covering everything from mobile strategy and road mapping to MCOE to UI UX design to mobile testing strategy, along with soup to nuts app design development and support. Additionally, Propellix offers 3 homegrown enterprise mobile products. So today I'm here with my good friend, Justin Yurasits. And Justin, now you are the head of software operations for the Fidelity customer contact platform.
I manage a large software operations suite for the firm.
So if you could just tell me how you got to where you are and what got you interested in technology and things like that.
Oh, sure.
Your background in technology.
So the chemical engineering was cool. It was actually really stressful. Unlike my current job in software operations today, someone might be unhappy about their experience, but back in the chemical engineering days, you had the chance to kill a man out in the plants.
Right.
You could really mess up in that way, and it was stressful and enormously intellectually complicated. Really, I don't think I was actually smart enough for that job. I'm not really sure how I even achieved the degree.
Well, I think we have that in common then, because I was in medical school at one point in Milwaukee, and they made it clear that was too difficult for me. So,
so this is working out just perfect for us.
Yeah,
then.
I think we've done all right for ourselves.
So anyways, it was a heavily compute-based program. Well, I was a chemical engineer, and I knew all about the nuances of subatomic physics and how to manipulate those types of things to act on my will. I didn't really like the field that much. It's very dirty and messy. And if you've ever been to a steel refinery or a smelter or a coal-fired wood pulp and paper plant, it's pretty gross. So pretty quickly, my career migrated towards, strangely enough, telecommunications. I spent quite a number of years as a telecommunications engineer, eventually an architect, designing internet hosting environments, a lot of security aspects of that. And then over time, a series of job changes, and I've moved over towards much more towards the software area, and now I manage both operations of a large software platform, and then we handle development for automation of operational practices.
How'd you wind up at Fidelity to begin with?
It was 1999, and so I wrote the word Cisco and network on my resume, mid-internet boom. And I had more job interviews and about an hour or two posting online than I knew what to do with. But I ended up, my mom worked in the technology area at Fidelity at the time, and she passed along my resume to a few folks. I got a phone call. I started out there with a 6-month contract, and
how long has it been now?
It's been 18 years.
Jeez, 18
I know.
years.
I'm heading towards retirement now, Steve.
I mean, I remember when I was a kid hearing about these
18
people
years seemed like a long time.
People who had pensions and stuff, and 30 years with a company, and people say that doesn't happen so much anymore. But
well, we'll see. We'll see. So, but that's how I got into the software operation. So long background across a number of different areas, both on the really deep technical side, either like programming or deploying or architecting technical solutions in architecture or software. And you can see through a few of these other stints, I've also managed on the business side with procurement, contracts, licensing, business planning, those types of things. So pretty broad-based career over the span of my time at Fidelity.
Yeah, that's awesome. So here on Device Squad, we don't normally talk about a single product or service. We usually provide an overview, but here's the deal. Justin and I are good buddies, and you said, I want to talk about Amazon Lambda, AWS Lambda.
It's awesome.
Run code without thinking about servers. Pay only for the compute time you consume. That's their main tagline here on the Amazon Web Services.
It is. And so in my current professional experience, what we really do is manage a very, very large compute installation. And in that compute installation, there are, I'd say maybe 50 to 70% of our labor costs, in addition to a very large percentage of our capital and operating expense goes to operating the platform. So behind the scenes of that fantastic mobile app that's out there is usually a team of tens, if not dozens of people who are responsible for things like scaling the platform, ensuring the compute environment is available, managing capacity reporting, trending on outages and alerts, and this whole slew of traditional back-end operation, which again, in my estimate, is 60 to 70% of the total cost of operating the platform. And in terms of the expense, one of the big factors in the expense is the level of expertise you need on staff in order to manage this type of environment. You need guys who are experts in computers, in servers, in Linux, in database, in various aspects of programming, middleware. So it's not just expensive, but the kind of people you need to do this is really difficult to find in the market, especially good folks who are capable and professional and able to come in and help you with this. So it's an ongoing problem, both from the cost, the staffing, and I've kind of dreamed in my own of some different way or simpler way to handle this. Now, everyone's heard of cloud services and the idea of cloud. And for the most part, the value proposition is instead of you having a data center and you having the servers and the real estate and the cooling and all the rest of the stuff that goes along with running that type of facility, that you'd essentially outsource the management of the facilities and the compute to somebody else. So you'd go to an Amazon or a Rackspace or an Azure, and you'd procure your server environment from them. But by and large, you're still in the same situation where you're just simply managing compute resources somewhere else. You still require all of this type of expertise and expense and time to manage the application and to manage it well. Like everyone's had their good and bad compute experiences, and typically the bad compute experiences somewhere in the back end there's not enough people, or there's not enough resources, or things haven't been scaled properly, and it just ends up as like a really lousy experience for the person who's trying to use your application. Somewhere around 2014, Amazon introduced the Lambda service. It was really the first instance in the marketplace of what they coin as the computerless, serverless environment. And so it's been here for about 2.5 years, but really in the last 6 to 9 months, a few other aspects of either maturing the Lambda service itself or some of the other components of the mobile development ecosystem have come together. And I think at this point in time, Amazon Lambda is really ready for prime time. And so what it does and what it means is that it lets you run your code without having to provision or manage servers or infrastructure. You no longer need to have this large group of people who are dedicated. They're not developing services. They're not advancing the application. They're not really providing value in terms of features and functionality. They're just maintaining the environment. You have this large swath of folks. You don't need those folks anymore. If you can manage your code correctly, what Amazon Lambda allows you to do is it allows you to upload your code, which right now there's 4 supported flavors of code. So you can support Java, JavaScript, Python, and Perl. And you can upload your code to Amazon Lambda, and there's nothing else for you to do. You don't have to worry about scaling it. You don't have to provision any servers. It abstracts the entire compute interface from the developer and allows the developer to only deploy their code.
Are you guys using this at Fidelity currently, or no?
We're not.
You have
And
additional
no,
security.
this is this is a pretty new service, but being in the industry, I see a lot of trends, and I see this really creating a lot of buzz. And I think the reason why is the idea of like the no ops environment.
Yeah, sure.
The fact that we can go from this very heavily slanted towards operational models with staffing and expense to moving that labor and expense over from operations to actually enabling the application. And the real value is what the end user gets on the app, right? It's not someone patched the server tonight or those types of things. Nobody really cares about that maintain the uptime. You don't have to do that anymore. So this entire swath of back-end operations can be eliminated.
And now, is there any chance that Amazon will also be offering free Whole Foods items with the...
I think you could probably trigger an Amazon Lambda function to deliver you some broccoli. I think that's in the coming future, yes.
Now that they own Whole Foods.
Well, that's a whole other story. Not only do they own Whole Foods, they patented yesterday, as a total tangent here, but I saw in the news of them patenting an automated clothing assembly system.
Oh, my God.
So look out, Brooks Brothers, right? Here comes Amazon. You can walk into Whole Foods, get your body scanned, pick out a shirt, and have it delivered to your house the next day. It's going to change everything.
It seems like Amazon has, as part of their goal, the object of putting a lot of people out of work. Whether it's the robots in the
grocery store,
factories, the robots in the warehouses, or here now all of a sudden they're automating all this server stuff. So, what kind of impact do you think this is going to have on those employees who were previously hired to do all these tasks?
I think there's always going to be smaller shops. I think there's always going to be some need to manage the compute environment from an operations perspective. So what I think is going to happen is people are going to either retool and reskill, but it's going to be more challenging because one of the great aspects of the Amazon service, especially with Lambda, is the way it abstracts the technology from you. Mm-hmm. For example, in the past, if you wanted to upload your Java code to be run and executed in an environment, you actually needed to know quite a few things. You needed to know where your repository was. You needed to know the mechanisms of upload. There's a number of steps involved to actually get it out into the compute base to run and execute. With Amazon, it's a web page with a couple of arrows and a few mouse clicks. The simplification and the abstraction of the complexity of what it takes to do that is deep and wide. You don't really actually need to know anything about it. And in fact, the way Amazon's constructed the services, there's really no way for you to know about what's happening from here's my file, upload and run. You click these few buttons and your software is out there and ready to go. So it's really changed. So I could see people retooling and reskilling to understand more about how to provision in these new types of environments. I definitely see a big disruption in the compute industry, especially from folks who are more skilled and say certainly like Linux server administrators or database administrators. The way these services have been designed at Amazon, it's really brilliant. I've been around technology for my entire career, 25 years, and I've never seen anything that approaches the way Amazon has simplified the ability to execute on a major enterprise-like scale with mouse clicks and drop-down boxes. It's truly like a SpaceX-like achievement in terms of being able to take an entire data center environment and provide it to anybody, anywhere. And you and I could right now today go out and provision a giant compute environment and have it laying in wait. Now, if it starts to run, we're going to pay for what we use. Like that's the part of the model, right? We can, if we start running our big compute environment, the bill's going to rack up fast. But we can go out and deploy and develop an entire data center environment right now for free. The leveling of the playing field in that regard is unbelievable to me. While it's going to eliminate many jobs and it's going to really change the labor space, the fact that like 5 years ago, you and I could not go out and compete with like a General Electric or a big bank or whatnot because they had their multi-billion-dollar data center environments, and if they were going to put out big applications and provide compute power, well, they had these assets. That was the barrier of entry for people like you and me. You and I, that barrier of entry is eliminated. And in fact, I'd argue that we'd be better off by starting from scratch and consuming these types of services and not building any of the data center environment. We'd have a complete no compute environment. It levels the playing field where anybody can get in there with an idea and really compete now.
That's amazing. So who's the ideal customer for this? Is it like the Fortune 500 company? Is it like a smaller enterprise, a startup?
The ideal customer is probably somebody who's not burdened by legacy applications that require difficult or custom integrations, or businesses that haven't yet embraced some of the security, identity, and access questions around being able to manage customer data on-premise and off-premise. If you're already like a large enterprise or a large customer, you can certainly go out and use these types of services, but I think it's going to take a long time to really take advantage of the speed at which you can deploy, the cost savings which you can realize because of the efficiency. And so I think where this really opens up the competitive landscape is to the small to mid-sized company that has the big idea, but in the past couldn't execute because of capital constraints. If you can monetize your idea, if your idea for compute transaction can be monetized and you can lay on top of yourself a profit margin for the compute transactions that you're executing in Amazon, you can make money day one with zero capital outlay. You charge Amazon onto your credit card.
Yeah.
Steve, one of the interesting things that's not really part of what I wanted to talk about today, but is a key function of using Lambda is an API gateway. API gateway is common things. Many people use the gateway. Efficient use of Amazon Lambda really requires the use of an API gateway. For example, Amazon's API gateway, and I looked this up today in my billing structure, I can make 1 million API calls for $3.50. So That's a lot of API
pretty
calls.
good,
$3.50. What else could I get for $3? I mean, I can't even get a donut and like a coffee at Dunkin' Donuts for $3.50, but I can get 1 million API calls executed.
Wow.
For $3.50.
Well, I'm looking at this. There's this try Lambda for free. The free tier includes 1 million free requests and up to 3.2 million seconds of compute time per month.
The idea I mentioned earlier about you and I being able to take a mobile application front end, architecting that front end that relies on the API gateway, and we load our code with no servers, and all of our backend code relies on the compute-free environment here that Lambda is the star of the show of. You and I could create a very, very complex set of applications and really thoroughly test them for free. That's the leveling of the playing field. Like 5 years ago, if you and I wanted to do that, we'd have to like cobble together some servers in your back room, and even if we got it working with your servers in the back room when we launched our app, then we would face the classic IT scaling problem. Like, hey, we're getting customers, but now we need stuff in the back room. Now we're buying iron, we're buying servers, we're trying to get, and it's these startups are very kludgy. They're really hard to do. Not only do we not need any of that stuff, but if you look further in the Amazon Lambda services, the scale is automatically built in. We don't have to do anything to scale. It will automatically provision, propagate, and scale the compute transactions.
It's crazy.
What they claim there's no capacity limit.
Wow.
I mean, it might be interesting to try to get to their capacity limit, but if you and I did that, well, we'd go broke. We'd probably, our Amex would get oversubscribed. And then who knows what we did wrong. But it's amazing that leveled the playing field in a way that I don't think anything else really has. And cloud computing was out there before, and you could put your servers out in the environment and whatnot, but we don't need those guys anymore to do this. It's really in the hands of the developer now. The developer is freed from having to worry about scaling the infrastructure to support what they built. Mm-hmm. And that's what's amazing. So all of your resources can go to development, which is where all the values added in an application is providing functions that the end user wants and desires and finds useful for whatever whatever that service happens to be.
So just to back up a little bit and just give a definition, because when I first heard about this, I was a little confused that they're calling it serverless computing, but it's not serverless computing at all. It's just that you don't have to have a server. They have the servers.
They've abstracted, and it's pretty secretive. I've actually dug in.
Oh, yeah?
Because I've tried to find this. Well, one of the biggest, just for example, one of the biggest operational challenges that any company faces is having to patch their environment. My entire career, we've always spent a ton of time, with Microsoft security patches. We just had the big WannaCry virus outbreak, the leaked NSA tools. Millions of Windows devices were exposed. And so, for example, like everybody had to rush in all these emergency patches. Well, just that alone in a large compute environment consumes everybody for days. Mm-hmm. They've somehow figured out a way to create this layer of abstraction. And you can find out there are underlying Linux and Windows servers that support the environment, but they've created and developed a unique service to themselves where your code is stored, the underlying compute system is hidden or abstracted, and when the call comes in to run your code via an API, there is this like microsecond delay before the code is run, but they spin up some kind of compute environment to handle your request, and then they shut it back down. So yes, there are Windows and Linux servers underlying this, but you have no idea about them and whether or not they're taking them in and out of service and how they've pooled them and grouped them together. Or it's completely abstracted to you and it's completely abstracted to the service. So there is an underlying compute environment. You just don't have anything to do with it. And in fact, you can't have anything to do with it. All you do is upload your code to the repository and hit enter and you're finished.
So now, does this reduce risk as well? Because I remember there was that attack on Amazon Web Services that had repercussions all over the place. Does this have any impact on that? If everybody's on this Lambda and it becomes attacked?
Well, I suppose there's always that risk. Amazon's pretty secretive about their security posture and how they secure this. What they do make public is their global compute infrastructure and the way it's geographically distributed. So I think they're up to their 27th data center across the globe, and I think that this compute footprint for Lambda spans the majority of their global footprint. So there's a variety of ways I think that they've protected themselves in there. But it's an interesting point, and I think that's something that's to be seen. Is there a way to attack this type of service and create as more and more people go to it? The answer is probably yes. There probably is some way to attack it. However, in the big picture, I think Amazon's got a pretty good picture of being able to protect themselves and protect data and maintain their compute environment. So I think that's something that remains to be seen.
When I was looking at this, I was wondering exactly what kind of functions can this thing actually carry out. Well, I'll just read it here. It says you can use Amazon Web Services Lambda to build mobile backends that retrieve and transform data from Amazon Dynamo database, handlers that compress or transform objects as they are uploaded to Amazon S3, auditing and reporting of API calls made to any Amazon Web Service, and serverless processing of streaming data using Amazon Kinesis. So does that basically cover any possible function?
I think yeah. Amazon only really talks about, and they're marketing their service here, so they only really talk about how to connect to their backends in their literature. But if you go deeper and get the user guides, Amazon Lambda, once it's triggered, can execute an API call to any other type of service. So it's really an API gateway-based architecture where on the mobile front end, it really changes things and allows the developer, and many developers do this. However, I think there's a next level where people can go in the architecture of the on-device application to really lighten the processing and the size of the code itself that's delivered to the mobile device by more heavily utilizing the API gateway to Amazon, offloading all that processing to the Amazon Lambda service. And then Amazon Lambda, as you mentioned, they say that you can call all of our services such as the DynamoDB, SNS, their artificial intelligence, any type of interface that Amazon offers is certainly available through the Lambda service. But Lambda can also trigger other events as well, or other services as well, off premise and outside of Amazon. Anywhere you can get an internet connection and send a socket request, Lambda can execute that and also service in that way as well.
So, Propelix, my employer, we're a mobile strategy company. So we do, apps and mobile strategy for large enterprises. So how will this affect us?
I think it does two big things. I think it allows you a chance to lighten the load on the application delivered to the mobile device. And then I think it opens up an opportunity for you're probably run into a number of places where the enterprise either does not have the technology, the infrastructure, or the capacity to run the new set of mobile applications that you're developing. Maybe they can do it in a dev or some sort of development model, but to actually, all right, now we want to go live with this. And typically the enterprise, in order to support that, has to go through this really long and difficult. Remember my procurement experience. Well, listen, to procure servers and databases and licenses and funding, and at any enterprise, I don't care how lean they are, that stuff takes months. So what you've done is maybe you've come up with this great idea and you've really skinnied down the app and you're ready to, hey, we're ready, and we've tested it all out and it's ready to go. Okay, well, it's going to take 9 months for us to get everything in place. Mm-hmm. If you can offer a model that takes your entire application end to end, including the back end, and uses a service like this, you can help that enterprise. Everyone wants to go to the cloud or move off their own compute on-premise stuff anyways. You could use this as a different type of service offering where, listen, we can develop your entire mobile app and have unlimited scale and capability by using the new Amazon mobile development services. So I think it's a new angle on which to get your apps out into the market faster, out in the hands of the end user faster. And then it's, if the firm was interested in it, it's also a whole new set of services. Like, well, the enterprise generally probably isn't going to know how to use this. Right. So it's a whole configuration and operational guides and migrating all the code and stuff to this. So I think it's a great opportunity to look into this and figure out, like, how could this be part of our service offering?
Yeah, I hear what you're saying too about the secret sauce, hands-off sort of approach. There's a question on the Lambda site: can I access the infrastructure that AWS Lambda runs on? And it says no.
Yep, nope, you can't touch it at all.
No way. AWS Lambda operates the compute infrastructure on your behalf, allowing it to perform health checks, apply security patches, and do other routine maintenance. So
don't underestimate those three statements: health checks, security patches, and routine maintenance. Every single one of those, I don't care how good you are, that means expensive people.
Right.
And I'm not against expensive people, but expensive people, you want to add more servers into the environment, you want to add more health checks. So that idea, even though the mobile app and, hey, here's this great app and whatnot, you're really talking about a very significant shift for an enterprise to run a major suite of mobile applications. They have to add all this stuff today. If you can architect that in a way where you can use the Lambda services, you can allow them to sidestep that. Everyone's moving towards the cloud, right? This can be a big beachhead for them. Like, hey, we're going to actually run this on Lambda, which I think it's cool. It's sexy. It's hot stuff.
Do you think that all these folks will be reassigned positions as like Lambda?
Click the button and press upload.
Is that really all it is? I mean, it's just really just
if you go to the something that I'd encourage your listeners to take a look at. If you go to Amazon and you go to AWS and you search Amazon Mobile Hub, you'll come into their development interface, and on the Mobile Hub interface. And if you go and look at what it takes to deploy the code, test the code, scale the code, it's web-driven interface with mouse clicks and drop-down boxes. The only thing that's really complicated is your code. Like you got to really know how to write Java, which is its own special kind of guy, right? Who knows Java inside and out. But all the rest of the stuff that it would take for him to have deployed that, where he needed all these other experts to get involved in a room and all this, it's gone. So I think I think it's going to be a long time coming before people have fully embraced this. But I think for the IT operations professional, I see that as a shrinking market. What I do see growing is I see that the ability to enable code so quickly. I think these folks, some of these folks will transition to code. I've already seen a lot of people in my professional circles start to transition more to code or code management or managing the Amazon services. But if you were to go look at the Amazon Mobile Hub and look at things like the API gateway, the Amazon SDKs for mobile, and the way you basically click to connect to these different types of services, database, SMS, SNS, artificial intelligence, it's really easy.
Wow. And they have their own SDK, AWS Mobile SDK, that lets you link to things like, some tools that we use, Xamarin.
It's awesome.
Some of these, mobile app development platforms.
Yeah, I've set up a bunch of this stuff. I've been training myself in AWS and working towards some certifications just to keep myself.
Yeah.
Because I see myself, if I'm going to stay employed in the next few years, I better know how to work this stuff. So I have a large compute environment, and I've subscribed to and used some of these services. For example, I've tried to deploy and manage databases in the past, specifically like Oracle databases, and you really need to have a lot of experience effectively deploying an Oracle database. The Amazon DynamoDB, myself and my daughter messed around with it and had a working database in about half an hour.
Wow.
And the only reason it took half an hour is because the cartoons were on and we were distracted. I mean, it's really, really straightforward stuff. The way they've abstracted the technology is what's revolutionary. It's taken away the need to understand all the underlying commands and the thousands of settings that end up behind the scenes in something like as complicated as an Oracle database or a Linux server environmental variables. That's all gone. I mean, you do have to conform in a way you have to manage yourself to the standard Java SDKs and things like that when you use these services. But as long as you can standardize your code, that's where you can put almost all of your attention.
Is this kind of like the next evolution of where, companies like WordPress and also like Wix is another one, automated the CMS, content management?
Yes.
They automated that whole process and so made it so that anybody can create a website. And this is now so that anybody can create a backend.
Yeah, it's really just like that. And I know you've got some background here. Imagine developing a web page, in 2007 and what you had to do to effectively do that and where the tools are like Wix today, right? This is in the same kind of genre of taking the kind of specialized, in-depth, years of experience knowledge across multiple different disciplines to create a data center. And it's completely abstracting that away into like mouse clicks and drag and drop. It's this unsung story. I think the only other story that gets a lot of attention is Elon Musk's things like SpaceX and the fact that, an individual person in his company figured out how to, the first instance ever of landing an orbital rocket on a little, barge out in the ocean, like those types of achievements. This is an achievement to me on that type of scale. This is every bit as complicated, I think.
Yeah.
And is really remarkable. And nobody, I mess around with the other services. I'm not an expert in Google services or Azure or IBM services, but I've looked at them. Nobody's even close. Amazon is so far ahead of these other big technology players that, in my mind, I've stopped looking at them. I'm not interested in working on them. I'm not interested in knowing about them. Amazon's going to take over the world. I might as well line up and
give them your money. So, what do you think is next? I mean, if this is where we are now.
Well, like tactically, I think what's next is I think those who are going to compete are going to change their architecture, especially in your industry. I think that what you're going to see is you're going to see competitive price pressures, and those price pressures are going to be on the functionality of the application. And I'm not exactly sure how you guys probably charge for the development of an application or whatever, but it probably has something to do with the size and the scale. So somebody is going to come in and figure out how to take many of the things and the common services that you might build on the application. I'll bet you Amazon, and especially in the Amazon Mobile SDK, they've already built 60 to 70% of it. But what you have to do is you have to figure out what that is. Somebody has to go out and learn that. But who has that knowledge and who can take much of that type of work that was previously built into the application as a one-off development thing and reuse these services is going to be able to create a competitive application for a much lower cost. So I think you're going to see like an architectural shift in the industry where folks who really learn how to use these services and then apply them to their advantage are going to be able to price an application for much less.
So give me like a specific example of how somebody might use Lambda. What kind of services are we talking about?
Well, I happen to have a diagram right here, Stephen. For our listeners, I know you don't have the diagram, but
we can link to that.
Oh, good. All right, cool. So I'm looking at it as sample Amazon AWS Lambda mobile backend.
Yeah.
And so, at the high level here, there's a mobile user, there's a media file repository, and so the users authenticate themselves via the Amazon service. They go ahead and they want to capture some media from the repository. They log in, their content is delivered, but then they've got a few functions they want to run based on their content. So, for example, you have some friends and you're on a friend, some social app, and now you retrieve some content and you see your friend like, oh, they just logged in at down the street from me. I want to send them a text or an email via the application. So you're in the mobile app and like, oh, they're there. Let me ping them. Let me send them a text. That command is an actual Amazon API call to a Lambda service. So now the send text to my friend is an API call into Amazon Lambda, and the call goes in, and the Lambda executes the code that you wrote and deployed on the back end and goes ahead, pulls that user's information from the data store, and then uses the SNS push service to then push if it was a SMS, text, or email, and uses the Amazon backend to push that communication out via the application.
So this is assuming that we have a whole new application built.
Yeah, this would be
Lambda.
some simple Snapchat type of thing. Or the message isn't from phone to phone. The message is from phone to backend back out to the phone. So previously, the backend might have been a server on your premise that the command came in and ran on your site. You don't need that server anymore. You just have the API call from the app, hit your code, you do the API call to the Amazon Lambda, and the Amazon Lambda code runs, and then it executes the instructions on your behalf, and then whatever those instructions happen to be, it makes that next party call to whatever the service, or in this, our example was an SNS push of a text, right? But that's like a really simple example of how you can use this type of service.
A lot of what we do involves like streamlining of, legacy business processes. Sometimes there are processes that haven't even been digitized yet. They're still doing them on paper.
Oh my gosh.
That happens a lot. And a lot of times the pushback that we'll get is like, well, paper's cheap. But do you think this is well suited to that? I mean, they're sort of standard kinds of processes of just data being passed back and forth, and people being updated on the data. And we're either building sales tools, or we're building apps for processing loans, or we'll build really complicated calculator apps for drug companies. But I guess if I break it down, a lot of these apps are really at a very basic level performing the same functions of just transferring data back and forth, essentially.
That's an awesome use for Lambda.
Yeah.
That's an awesome use. You fill out the form on the phone.
Yeah.
You gather up the metadata. You attach it to the API call. You send the API call to Amazon Lambda, and anything you want to have happen. You want that to go to the database. You want that to go to the database, and secondarily, you want to send an SMS text to the group associated with that data in the database. I mean, anything you can conceive of with that type of data and the way you can push it with Amazon Lambda, you can do. And then recall, like, the paper is cheap, but recall the $3.50 per million API calls. I think $3.50 is, I don't think you can even get a ream of paper for $3.50.
Right.
So if you can do a million API calls for $3.50, it's not just competitive with paper, but if you can help these customers move from some file cabinet based system to a robust, redundant, reliable database, such as having everything stored and all your transactional history managed in a real industrial strength database, such as the DynamoDB service. That's an example of Amazon's database. I think that's kind of a compelling case. It's pretty cheap. I think you'd find the compute services are really, I forget the cost per, I know it's $3.50 per million API calls. I know that Amazon charges the Lambda on the, down to the 100 millisecond level for executing the code. I forget the cost, but it was like 6 or 7 zeros before those, like the decimal point, 6 or 7 zeros, and then like a 7. So you'd have to run a lot of code to actually generate a bill. So I think it's and then there's no environment to manage, Steve. They don't if they're not using it, there's no bill. Like all the code and all the database, if you're not using, I mean, it's transactional based. So for some of these firms, that it would be daunting to go. Server's $10,000.
Do you think that'll change?
I think the price will go down.
Really? I mean, do you think that you don't think they'll switch from like just a monthly rental model? Like a lease kind of model.
Well, I mean, it's. I think everything's gone to the transaction. No, you can't.
That's
well, that
amazing.
model's there, Steve. I can. We're completely bypassing Amazon's classic service, cloud service, EC2, where I can go into Amazon and I can provision, any kind of server I want, and so I can provision a server, or I can be more directly involved in the management of the compute environment. But that's where. If you're talking small to mid-sized firms that you do your work for, they don't have anybody who can manage that kind of stuff. They don't. I mean, a small firm has got one or two IT guys. Now they're going to manage the mobile app deployment. You package this whole thing up in the Amazon service, where they're just receiving a bill on their corporate Amex each month, which is highly detailed. It shows everything that happens. There's nothing to do. It's like your phone bill. The phone bill comes in, and then you guys manage that as a service. So like a managed service option, which is where, I think there's actually a real opportunity for profit. You built the app, but now we're going to put you on Amazon service. You have nothing to buy. You're going to pay only for the transaction you use, and we'll manage that environment for you for and whatever number you can say that you think's reasonable. But I think it offers a whole new model for the business of developing the applications in terms of being able to manage them moving forward. And I think it actually opens up the market, because I think a lot of the resistance is in, well, how am I going to manage this when you guys are gone? You don't have to. There's nothing for you to manage. It's all.
And they take care of all the testing? I mean, I'm just seeing here, how do I troubleshoot failures in an AWS Lambda function? And it says Lambda automatically integrates with Amazon CloudWatch logs, creating a log group for each Lambda function and providing basic application lifecycle event log entries.
It's standard stuff. So I've got CloudWatch running, and so Java, and I'm more familiar with JavaScript, but they both have their own native outputs for errors in running code or whatnot. So those types of errors are errors and environmental problems and things of that nature. CloudWatch is basically their operation center application, where you go in and see, if you had servers, like I've got a bunch of servers built, I could see the servers and there's CPU history and trends like that, but all the logs and logging available from the application, all the same standard logs you'd scrape from a Java application in your compute environment can get shipped over to CloudWatch. So you have the same ability to see, oh, hey, why isn't this running? Well, go grab the logs, right? Well, they're just over in Amazon CloudWatch. So it's really similar experience to what people are used to developing with an on-premise compute.
And it supports versioning, and it says deployment times may vary with the size of your code, but Lambda functions are typically ready to call within seconds of upload. And you can use your own version of a supported library if yours is different than the default version.
Yeah.
That's incredible.
It is incredible. The API gateway, which, maybe the next time we talk, maybe if we have another one of these, Steve, we should talk about the API gateway.
Yeah.
And then we should talk about the mobile hub. Because the API gateway, for example, one of the things that's really popular, and you guys probably do this, I know a lot of software folks do this type of thing, but is the A/B type of testing, where, hey, I've got 95% of my users on this code, but I want to put this one out there and just have a few people hit it and see what the feedback is. Mm-hmm. So the API gateway is very extensible to a number of different functions. So one of the things it's extensible to is to round robin or many different types of calling the Lambdas. So I could have my primary API gateway call to my known good piece of software that's out there, and then I can add a second Lambda to be called either 5% of the time or for a specific set of IP addresses or any kind of way you could imagine, very load balance or like. But you can easily take your code in and out of service. You can, by using the API gateway, you can manage what components of your Lambdas are being called. The flexibility with this, it's really awesome. Why anybody would do anything else or like put stuff on-prem anymore, or I can't understand. And if you go back to the beginning, you talked about, hey, you can have like a couple million seconds of compute time and a couple of million transactions for free every month.
Yeah.
I mean, you could really do most of your development here for free.
That is their free version.
Yeah. The free version is the exact same thing as the full version. There's no difference. All that happens is you kick over the threshold, you're going to start to pay. You get past your million transactions and your 3.2 million seconds, then now the bill kicks in.
And of course, you can create an Alexa skill using Lambda. No big surprise there.
Right. Well, where would we be without Alexa?
Yeah, I don't see anything about the OK Google.
Yeah, the Amazon literature is slanted. I do agree with that. But if you go through the literature, it is pretty open for a proprietary service. I wouldn't really call it proprietary. You can really make API calls anywhere.
So do you have any examples of who is using this currently, like the largest maybe accounts that they have, or I'm just curious to see how it's being used. Or do we just not even know?
Well, I know that Periscope, Yelp, Airbnb.
Periscope, which for people who don't know is Twitter's live video streaming,
and Hike. It's a messenger service. Yeah.
Yeah.
They're all heavy users and heavily deployed, and I believe both Yelp and Airbnb, from what I read, their entire application suite is serverless computing on Amazon Lambda. They have no data center infrastructure. It's completely built using this service, and that's what I think is going to be the big competitive change in the landscape. Is actually learning the Amazon services like the API and the Amazon Mobile SDK, being able to take the kinds of functions that you used to have to build on an application by application instance, figuring out how you can map that into the already built feature set that Amazon offers, and then really skinnying down the development cycle to the minimum that you can, and being able to offer a, maybe not lower cost. I mean, who knows about the costing model, but I think there's big opportunity for financial gain here for folks who know how to use the service. And that's where you asked, where are these people going to go? As you and I sit here and talk about the Amazon SDK, I've looked at the Amazon SDK. It would take a while to get your hands around that, but that's where I see a lot of these people going. If people make the shift from like, well, I used to know this server stuff really well, and now my job's moved over to this Amazon API thing. Let me go and figure that out. I think that's where folks will go. That's where the knowledge and the value is. I see shifting is moving over to really understanding and being able to manage those types of services.
So do you see this as having the biggest benefit for, I mean, it sounds like mostly like sort of mobile slanted social media.
No, I just focused on that slant because I knew that was of interest to you and something that we talked about. I'm actually selfishly, as an operations manager and someone who designs and runs large backend compute systems, I'm looking at this as ways to really dramatically shift the value proposition of what I do and the labor that I manage into ways where I can stop many of these functions that we do that are really non-value added. Imagine a large compute environment with 2,000, 4,000, 10,000 servers running, who knows, 50, 60, 70,000 instances of applications.
Right.
And now WannaCry comes out, and WannaCry is really just a Windows-centric attack, but imagine having to go in and secure that environment every month and respond to ad hoc events that come up just purely from an operating system patching perspective. Those types of situations can consume thousands upon thousands of hours of labor, for which the value ostensibly is that I secured the environment. But what has happened for the end user? Has anything happened for the end user of my applications? Has anything improved? Has anything changed? Has anything been streamlined? And so I consume all of this resource. But in my mind, and going back to my chemical engineering days, where we spent a lot of time with ideas of like lean manufacturing and Six Sigma, you really look at the steps in a process and ask yourself, did that step add any value? And did the time between that step and the next step add any value? And when I look at those types of events, I think the answer is no. Across the globe, there's hundreds of thousands of operation people like patching servers to no end, and I don't think there's the slightest whiff of value installed in that. So I think the bigger play for this, outside of the mobile, is the enterprise. If the enterprise can move to consume this type of compute platform and transition the people in those thousands upon thousands of hours of labor from keeping the lights on to more focusing on enabling features and functions that provide more value, I think that's the huge win. Yeah. And so being able to transition to that is where I think everything's going. I'm very interested in it. And then honestly, a lot of this operational work, it's good work. It has a lot of people employed. You can only patch the server so many times before you're, I'm good. I've patched, it really is not the most exciting kind of work. So I actually think that if we can transition people from kind of some of this more mundane routine work that doesn't really add a lot of value, and help these folks reskill and change their ability to contribute in a way that does add more value, I think it's going to really change things. The problem is going to be adoption, especially at the enterprise level. It's going to be really hard to adopt and the transition, especially older or bigger companies. It's going to take a while, but in that phase, I see a lot of disruption. I see a lot of young competitors being able to go in and do things much more nimbly.
A new company can come in
really fast.
That doesn't have
really fast. I mean, if you think about it, like we talked about another point before, there was a barrier to entry to major either mobile or enterprise applications, and that was the back end data center compute environment.
Yeah.
And if you want to compete with Mr. Big Guy, well, I've got a $2 billion data center. Compete with that, right? But now I can do it. You and I could do it faster here in your barn/office than the enterprise guy can. I mean, we can blow him away.
I wonder if that pressure alone will be enough to persuade some of these companies at least to start looking into this.
Well,
and
I
getting
think
the ball
any
rolling.
enterprise that's trying to survive recognizes the changing competitive landscape and the ability of new companies to. So I think this is on every CIO's radar about how do I transition and change my cost model from, I don't know what the numbers are across the industry. I see them in certain industries, and I think operational expense, and then if you look at the operational expense and you look at the labor component, I think operations labor is like 30 to 40% of the total cost of compute. And maybe even higher in some places, maybe even like half the total cost of compute is operational labor. So if you could transition that expense, which can be really large at a big enterprise, into value add, it's a complete game changer. And if those who can't, there will be somebody who will come along and
right, exactly,
blow your stuff away, have much better apps, they run faster, they infinite scale, and especially if you can monetize those transactions. If you can make money on the transactions, you can find out exactly what it's going to cost you to run your transactions through Amazon Lambda down to like the thousandth of a cent. So you can figure out, hey, I'm running this app, I'm doing this, I'm pressing this function, what does it cost?
Yeah.
And if you can make money off of that, it's awesome.
Is there any like energy savings for companies of not having to run if they have their own servers running 24/7?
Absolutely. If you think about, the power supply required to run even a small data center is that of like a couple of city blocks.
Yeah.
So Amazon, and moving your servers to Amazon, you avoid. Jesus. Oh my gosh, the chickens!
Girls.
I know.
Girls, come on.
So the operational expense, I talked about the labor, but the real estate,
right?
the cooling, the heating, the power, the lights.
Cooling, right? You gotta cool.
It's a lot. In Amazon, again, they're pretty secretive about this, but the efficiency with which they run their compute assets is, maybe unrivaled in the world. Meaning they've got so much iron, so many virtual machines, so many CPUs, and so many cycles available to them. And the way in which that they're able to optimize the utilization of that compared to power, space, is no enterprise can compete with Amazon. It's not possible.
Right.
That they're solely focused on this as the leading edge scientists in the world in this regard. So that some guy or some small to mid-sized business is going to spin up their own, whether it's a colo or they're going to consume compute resources somewhere. They're always going to have stuff idle. They're always going to have idle cycles, and these guys really are at a whole nother level with that. So yes, I completely think that in terms of like power, cooling, space, real estate, those are a whole nother series of costs that we didn't even talk about that are now offloaded from the firm subscribing to the service and really optimized by Amazon.
That's amazing, but they still won't take care of my chickens.
They won't, but I'm looking forward to getting my Brooks Brothers suit at Whole Foods. That's where I think that's where it's going to really hit the ground for me, is when I can walk in, get my body scanned, have some cap toe shoes delivered, and a new suit jacket with my organic blueberries. It's gonna be awesome.
Maybe they'll like scan your body and then determine like how your diet needs to change based on your current fat content.
Yeah, they could take that and send it to Amazon Lambda, and then they can do the compute in the background, and
then they'll just ship you the food every week that you need. Who knows? I mean,
who knows? I agree. It's fascinating times.
Linked to an insurance company that is pushing that program to make people healthier. It's a crazy world. Justin, thank you for coming by.
No, it was great. I really appreciate the chance to come by. I always enjoy seeing you, Steve, and getting the chance to talk with you. And, these topics like compute and servers and operations, these really interesting stuff to me. So it's a pleasure to get to come out and speak with you today, Steve.
Thanks, man. I think this has been a great introduction to this Amazon Lambda, and I hope everybody out there has found this helpful. And thank you all for listening in to another episode of Device Squad, the podcast for the mobile enterprise from Propellix. All right, bye-bye, everybody. Oh, the chickens got quiet. They're like, oh, he's done recording. Let's keep it down. The only podcast that comes with the possibility of contracting salmonella. So good luck with that.
That's awesome.